You're on mute, Katerina.
Welcome everyone to our translation to our webinar on UML diagramming. Let's wait a minute till everybody is joining. And yeah, hello to you, Tomasz. How are you doing today?
Hello, Katerina. Thank you. I'm doing quite well, thanks. A bit nervous.
Good. Let's see if we have everyone. Okay, so looks like we can start. Um, Welcome again to our webinar on UML diagramming. So today our speaker Tomasz will give you a lot of insights and practice an example of UML diagramming. So he's been an expert in it for many years, so I'm sure you will have a lot of useful information. And in the end, we will have also Q&A session. So please leave your questions either on VR community page or on YouTube. So Tomasz will answer them in the end. So passing my word to Tomasz, let's start.
Thank you, Katerina. Welcome everyone to the webinar. Today's topic is the UML in practice, and we'll be focusing on structure diagrams. My name is Tomasz Miodek. I am a Chief Business Analyst in EPAM Switzerland. I am working for EPAM for almost 5 years now. I have already over 14 years of experience as a BA and an overall experience of over 25 years in IT in general. I'm mostly working with insurance, especially as a BA. However, I also had the ability to work with other industries. So I hope that you will find my presentation useful, especially that even though the examples will be insurance related, I assure you that you can use it also in all other areas as well. I am a UML certified professional, so I'm holding the OMG OCUP UML Foundation of old version certification. I also was a guinea pig for the all levels of the new version of the UML testing. So the content of today's webinar will be first, I'll talk about the context of my presentation. Then I'll show you some class diagrams and examples how they can be utilizing the UML to present the so-called domain. Then I'll be showing you a bit of object diagrams and where they can be very useful. Finally, I'll touch on some other diagrams, and we will conclude this session with a short Q&A. So let's jump in. The goal of this webinar is to see real-life examples of UML diagrams. I'll help you also familiarize with the most important static diagrams used in UML. I'll try to show what are the typical elements occurring in those diagrams, how can you use them, and finally, I'll be showing what are the possible benefits of UML and when can it be used. I'll be briefly mentioning what elements are visible on the diagrams. However, because this is focusing on practice, I'm not going to go into completely theoretic knowledge. Even though it's not required, I assume at least some basics of UML are either known or at least the basics of the software engineering. Of course, this presentation will also not cover all possibilities granted by UML. We are focusing on things which are really most often used. I will be referring to real-life projects in this presentation. So the first one is in, of course, insurance company, where we were replacing a claims platform. This was a really extensive project with a lot of challenges. We had dependency on the policy data. There were various options required by the client for these claims to cover. So, for example, different types of insurable objects. Generally, all lines of business had to be covered. So this was really, really one of the biggest projects actually I participated in. And I'll also be mentioning another project where we had to combine the data from various sources for the retail underwriting in automotive. This was actually introduction of a new enterprise service bus solution, which required merging data from several internal and external sources. So it really, really required a focus on integration and the architecture of the system. As you probably know, UML consists of 14 types of diagrams. However, not all of them are as commonly used as others. So I will be primarily focusing on the most used diagrams, which currently you can see here marked as a, let's say, darkish green. I'll be also mentioning some of the less often used but still quite useful diagrams, which are now highlighted as a light green. The rest, which is left white, they are useful, however, neither in like the everyday BA work, nor in every project. It doesn't mean you don't need them. However, I really use them very, very rarely or never. This session is focusing on the static side of the system. So I'll be talking only about the structure diagrams. We will be having a second session probably in a couple of months that will be covering also the behavioral part of modeling. Let's jump into the class diagrams then. I'll be presenting a couple of examples with increasing complexity and introducing new diagram elements with those examples. So the first problem that you can very often encounter is you have different types of something. In this case, as I've already mentioned, of insurable objects. So it's really good to be able to see and understand the logic of that. And with that, the class diagram is very helpful. So you can see the rectangles are representing classes. We have classes such as the insurable object, vehicle, land vehicle, and some others. And those classes can have certain properties. So we can see that, for example, about a vehicle, we can tell that the vehicle has some kind of an engine with the engine type. It can have some kind of a registration. Well, probably you have a car, so it's not a surprise. It can have some kind of a chassis number or VIN number, and so on. We can also have methods presented. However, in the typical BA world, they are rarely used. This is more useful for the design of actual system structures. We can also present the properties in an association way. So we can see that the insurable object is somehow related to a location. This relation is called association, and it shows there is some kind of relation between those two objects, not specifying exactly what kind of relation it is. Typically, this is explained at least in some way on the arrow itself. You can see that the arrow has a so-called open head here, and it's a solid line. The name location here is how this element, the location, so let me maybe highlight it here. So this location here is showing that this element, this class, is actually an attribute of this class. So inside the insurable object, we'll have the attribute location that will be of type location. And that's very important information that we can actually use any class as a type for any attribute within other classes. Another element that you can see here is the multiplicity. So those numbers here, actually numbers and symbols below, are representing the multiplicity, which shows, okay, how many elements of that exist in this relation. So we can see that we can have 0 or 1 location related to a specific insurable object, whereas location can be linked to multiple insurable objects. Another type of relation which can exist between the classes is a generalization. It is represented by a line with a white triangle or like empty triangle at the end. So this means that the objects which is at the triangle end or at the arrow end is a parent, whereas the objects at the beginning of the arrow are children. And as we can see, it might be actually a more complicated structure. So we have an insurable object, then we have vehicle, property, cargo, and so on each of them being an insurable object. We even have a person here. Then we have land vehicle, for example, car or motorcycle, vessel, and aircraft as special kinds of vehicles. The idea of generalization is that any child class can be used in place or in role of its parent class. And of course, it can flow any way up as we need. However, we can add or modify how do we handle certain properties or what kind of properties do those special classes have. You can also notice that the name of insurable object is actually written in italics. This is because this is an abstraction class. So this is a class that never can be directly instantiated. You only have the ability to use any of its children instead of it. So in real life, you never have such thing as insurable object. You will have specifically vehicle, or even more specifically, for example, a land vehicle, vessel, or aircraft, or any of the other classes which are underneath available for this insurable object. So let's move to the next example. Here, the challenge is in the data structure itself. So we have a hierarchical data structure. That's an actual data, how the addresses are stored for Poland. And we can see a hierarchy where we have the top level, which is the country, not visible here. Then we have the province, county, municipality, city, and so on. So we have a whole structure. And when trying to do the first diagram, it looked kind of like that, which doesn't look too good, actually. You see a lot of connections. You see, if you look clearly, you see really repeating elements. So we have really the same attributes in all those classes. So that wasn't actually the best representation. What I did as a result, a rethinking of that, I came up with a diagram which looked like this. And you can see here now that the multiple elements of the hierarchy has been collapsed into a single node called administrative unit. Now, how is it possible? Well, we have a self-reference. So you can see this arrow here. I'll also explain this, this format in a moment. So we can see that actually a class can be related to it itself. Now, obviously, the class is just a template for the actual objects. So it doesn't mean that the same object is related to itself. Well, it can, but in general, it means that objects of the same type can be related to each other. And in this case, those different levels of our hierarchy are represented and are related to each other, where a higher in hierarchy element is considered a parent, a lower will be considered a child. However, of course, here we only can navigate from the child to the parent. So from the child, we see what the parents are. Now, here we are using this different type of relationship, which is stronger than association. This is called a composite aggregation. And essentially, it means that elements which are underneath, so at this end, are depending on the element at this end of the on this field diamond end of the relationship. So essentially, if I remove the higher level element, that would cause all the lower level to be removed as well. We can also see here a different situation, which is also quite often happening, where we can have more than one relationship between two different classes. So for example, here we have a location. A location, it's an abstract class, as you already know, has a special kind which is called descriptive location, in which case we can just describe where this location is. We can also have a different, for example, the address. So this is a typical location that you can think of, but we can have this descriptive location. Now, we can have a location like an address or anything else, which can have within it some sublocations. Think of it like a big property, and then you have certain buildings on that property that you can treat each of them separately. So you will describe them, and you will here provide the information. Let's say it's a house, it's a garage, it's a tools shed, and so on. So each of those will be under our main location. So each of those is also a kind of location, but they are all under the main location of the property on which they are located. So that's why we also have here the second type of composite aggregation again. So we can see that we can combine two classes with different types of relationships, and definitely can have more than one. We can also see that, of course, like earlier, we could see there was the multiplicity of 0 to 1, and also here, so we can have either 0 or 1. Here we can have any, but we can have a very specific number, like 1 in this case. Even sometimes we can have, actually, it's not here. I'll have it further, one-to-one relationship. But sometimes we can have even more complex. So, for example, we may have, well, almost any number, but the lowest number being 1. So postal code always has to be related to a specific address. You cannot have a postal code just existing in void in this example. One more element, actually two more elements which are visible on these diagrams are those green boxes. They are called enumerations, and they are green just because the tool I'm using is supporting that coloring. But they are indicated by the stereotype at the top saying that it's enumeration. Enumeration allows us to actually enlist all possible values which can be used within the particular attribute. Now, what is important? Enumeration is not a class, so it cannot be linked through an association. So we are using even a weaker relationship, which is called a dependency. Dependency says only, okay, this class, street in this case, needs to know something about this enumeration. This something in our case is actually using it as a type. But like I said, it's not a class, so it cannot be associated. This relation, this dependency can refer to any kind of situation, but essentially the idea is a class which depends on something else needs to know something, but it's too weak to call it association. You can also see that we have types of attributes mentioned here after the colon, and this shows the implicit information that we depend on the street type. However, showing it explicitly on the diagram is very helpful to actually make it easier to recognize and understand those diagrams and those dependencies. Next problem is the situation where we have multiple deductibles. So as I was mentioning, we are talking about the insurance world here. Deductible is the part that you have to cover from your own pocket in case of using your insurance. So the deductible can be related to different elements, for example, policy coverage and covered risk. Now, you remember that the composite aggregation or composition means that the element at this end is actually directly linked to that element and depends on that element in a way that if we remove this one, we remove that one as well. However, sometimes that's not the case. Deductible can be linked to multiple different elements, and we cannot say, oh, well, it will disappear together with that. So as a result, we are using a weaker relationship, which is a shared aggregation, sometimes called just aggregation. So shared aggregation is stronger than association. So it also is an association. You can see it by being able to use those labels here as well. However, it's weaker than composite aggregation. Another element that you can see in this diagram is nodes. So like I said, we have those three connections, and you can see each of them is having 0 or 1 multiplicity at this end. But the node says that this actually is XOR. So we need to have exactly one of those three existing for the deductible. So node can gives you the possibility to put any additional information which otherwise isn't directly supported by UML. For instance, you can enter this kind of constraints which are really touching multiple elements. We will also have constraints like that, which are applicable to just one element that will be actually visible directly inside of the of the class. And the further you go with the project, the more difficult the diagrams become. So this is actually a case where we want to understand how the claim, the central bit of the project, as you can imagine, looks like. And you can see that claim not only has a lot of elements which are claim specific, like claim request, like the claim participants, but it is also depending on elements which are actually from other areas, from other packages, things like loss events, which are part of events, things like policies, which are part of the policy. Again, I've mentioned that it very heavily depends on the policies. Parties, which represent essentially any person or company that might be involved in the case, and so on and so on. So with the increasing complexity, of course, different challenges are appearing. We can, for example, see here that the claim request can have really multiple types of cash amounts referred. So here we have the amount which is requested by the claimant, the amount which is actually estimated, the amount which is recognized as the actual loss, and the amount which is the final reimbursement. I'll come back to that example when we'll be talking about objects. One more element which has shown here now is a data type. A data type is weaker than a class in a way that it allows us to build a structure with different underlying data. However, the classes, so the objects which are based on classes, are always separate instances. And you have two objects with exactly the same values, they will still remain two separate objects. In data types, if we have two attributes having exactly the same structure of the data type, we do not distinguish that those are two different data type representations. They are just considered the same. And they are useful sometimes to just build a more complex data structures. So that's why it's called data type. In this case, we can not only have in our enumeration the name of the role, but we can also say, okay, this role can also be used within the policy participation and not just within the claim. So this is a special case which sometimes is useful. And I could actually add here the constraint that the policy participant can only happen if the is policy is true. So can only use this type of enumeration elements. So why don't we show everything on a single diagram and bring it all together? Well, of course, there are benefits of a single diagram view. You can have one place to find all the elements. You can see all the connections. You have everything at a single glance. But at the same time, there are also drawbacks. The diagram can become really large, really complex, very difficult to read, and huge in size. So it's not always useful. And at the end, it's just difficult or impossible to organize without crossing lines, which is really kind of a golden solution. So let's have a look, because yes, those are used as well. That's how a diagram with all the elements looks like. And if I zoom in a little bit, so for example, here you can see, yes, we have those cash amounts, we have those claims, we have policies. Let me move maybe a little bit to the side again. We have policies and everything related to the policy here, and so on and so on. So it is very useful. You can actually track relations. You can see everything at a glance. You can see dependencies. So for example, if I change this single class, I can see how many other classes are being affected immediately. But it's not useful if I only want to explain one specific relation between, for example, those cash amounts and claim requests. Okay, enough about class diagrams. Conscious of times, I'll try to speed up a little bit. Let's talk a little bit about the object diagrams. Object diagrams allow us to show the specific representation, specific actual implementation of those classes, the real life relations existing in business. So we can explain specific dependencies through the diagram. On such diagram, we will have some objects, again represented as rectangles. However, this time the name of the object is being underlined. We can have either just the type indicating what it is, or we can have a bit of a different situation where we also have the name helping a little bit to understand what exactly is behind this object. So for example, this is the structure I was mentioning, where we can see the actual specific example with different levels of the province, county, municipality, city, and even street. The left hand shows, on the other hand, the dependency between the claim request and different types of amounts that are related. So again, it shows, okay, yeah, we start with original 800 as the request amount, but actually the reimbursed amount in the end is 550, and the whole of it can explain why. So that's why it's sometimes easier to understand the structure. Then object diagrams help understand the business in general. So we understand there is a claim, we understand there is a policy, but how are all those things related? A single diagram allows us to really show it at a glance, verified with business, and then present to the developers. So it's a really very, very powerful tool that allows us to easily show all the dependencies on the business level, on a level which is understandable for everyone. And it also can be used to validate a model. So we already have built our fancy diagram, but now we can check, okay, can we actually handle all the special cases or all the difficult problems that might arise? In this case, we can have a loss event for which there are actually two separate claims raised by victim and by the perpetrator. Then within each of those claims, we have a couple of different requests. So one for the car damage, the second one for the injury. Similarly, on the victim's side, also the damage and injury and the replacement car. And everything then is related to the policy, and we can see how this policy actually has respective coverages, which helps the claim adjuster to understand, does actually this whole claim work and can we reimburse that? So that way we can see, okay, can we handle all those difficult business scenarios? Final part of our presentation will be about the other diagrams. I would actually focus only on one, which is component diagram, which allows us to show a bit of an architecture. So here we have components, which are shown with this single icon here. These are the parts of our system that interact with each other. We have interfaces, which are indicated here with a ball socket notation. That shows the interface which is required. That shows the interface which is provided. And overall, we also have ports, which allows us to group related interfaces. And we have the assembly connectors, which show us the relation between the provided and the required interface. So in complex cases, we can also have a delegation, which shows that the bigger interface is actually being handled, specific interfaces are being handled by sub components of a major component. This is useful, especially for more technical projects. So that was it. I hope you found my presentation useful. I'm afraid we don't have time for the Q&A. Katrina.
Yes, no worries. If anyone has any questions, you see the contacts of Tomasz, so you can contact him in LinkedIn. And don't forget to press like if you're watching from YouTube and give a thank you badge if you're from EPAM. So thank you all. Thank you, Tomasz, for a wonderful talk, and have a good Friday. Goodbye.
Thank you, Katrina. Thank you all. Goodbye.